Okay, section 2.13 deals with making a problem a perfect square trinomial, something that isn't really a perfect square trinomial, making it one, and then taking away whatever you've added into it to make it look like a perfect square. Let's just do a problem. Let's just do a problem for practice. Problem 1, b to the 4th plus 64. If this were a perfect square, it would have a middle term that would be 2 times the root of the first term times the root of the second, which is just 2b squared times 8, 16b squared. So, I'm going to write it in the factored version as if it had been a trinomial, perfect square trinomial. Like that, squared. If you work that out, you'll find that our middle term is indeed going to be that. B squared plus 8 times another b squared plus 8. Let's work it out. B to the 4th plus 8b squared plus another 8b squared plus 64. Okay, yes, it does. That comes to a perfect square trinomial. So I'm going to write it like this, but in order to stay true to my original problem, to have it only equal those two original terms, I've got to take out a 16b squared. So my final answer is going to be, I wrote it, this is my original problem, I write it as if it is a perfect square trinomial, then I take away what got added into it. Okay, let me write that down here again. It's going to be b squared plus 8 squared minus what got added into it that wasn't in there originally, 16b squared, or I'm going to write it like this, 4b squared. I'm hoping you'll see the pattern. I have something squared minus something squared. This is a case of difference of two squares. So that's why we wanted to manipulate this problem like we did, so that we could work it out like a difference of two squares. When you have a difference of two squares, say it's a squared minus b squared. You arrive at that binomial with two squares to the same power, and there's a difference. You arrive at that by having a plus b times a minus b. Same kinds of variables or numbers being used. One's a sum and one's a difference, and they're being multiplied. Comes to a squared minus ab plus ab minus b squared, which these two cancel each other out. A squared minus b squared, that's what it comes to. This is how we factor them. So seeing as we have a difference of two squares right here, we need to factor them just like I did this example right here. So let's factor them down here. You would have, let's pretend this was the a squared minus b squared. We're going to factor them by saying our a, which is a big clump of b squared plus 8, a plus b, b squared plus 8 plus 4b. Notice I'm not putting my squares down because I'm writing it out. B squared plus 8 plus 4b times b squared plus 8 minus 4b. A plus b times a minus b. That's what I just wrote here. This is my answer. Abeka will want you to write it a little more correct with the variables dwindling down until you just have a number. So since we can't really add any of these, I can forget about the parentheses. They just help me stay organized and remember that this is my a value and this is my b and this is my b value. Just helps me remember that. But in our end answer will be b squared plus 4b plus 8 times b squared minus 4b plus 8. So there you go. All right, let's do problem 2. A to the 4th plus 4 b to the 4th. Okay, so if it were a perfect square, our middle term would be 2 times the root of a to the 4th times the root of 4b to the 4th, which just comes to 2 times a squared times 2b squared, which comes to 4a squared b squared. That's what I'm going to need to take away when I make this a perfect square trinomial. Okay, let's do it. Let's make this like it had been factored from a perfect square. A squared plus 2b squared squared would work out to that whole long string, a to the 4th. This would work out to a to the 4th plus middle term 4a squared b squared plus 4b to the 4th. That would work out to that term. So I know what it's going to work out to, but I know what I'm really trying to say from the original one. So I'm going to just say this minus the extra that I said was in it, but that's not really in it, minus 4a squared b squared. Abeka has engineered these to work out. This is a squared value if you write it correctly. So we've got a squared plus 2b squared squared minus, let's write it the right way, 2ab squared. Now we have a difference of 2 squares. A plus b times a minus b. That's how you factor a difference of 2 squares. So let's just write it like that. A squared plus 2b squared plus b plus 2ab times a minus b. A minus b. Okay, wow, that is our answer. But we want to write it in the correct order. We'll write this one first, then the middle term, then the last term. That's how Abeka would want you to do it. A squared plus 2ab plus 2b squared times a squared minus 2ab plus 2b squared. There you go. That is your answer for problem 2. All right. Let's try ourselves problem 3. X to the 4th plus x squared y squared plus y to the 4th. If it were a perfect square, it would be 2 times the roots of either side. So let's write it as if we had factored a perfect square. Just like that, squared. And then let's take away what we've said it has in it. We've said it has this in the middle, but it really just has this in the middle. So let's take away 1 x squared y squared. That way when we work this out and it comes to x to the 4th plus 2x squared y squared plus y to the 4th, and it comes to all that, we can take away just 1x squared y squared and leave us with what we originally had, which was just this. So I've got that perfect square minus another squared value. Let me write it like that. Okay, minus xy squared. Difference of 2 squares. So let's write it as x squared plus y squared plus xy, a plus b times a minus b times x squared plus y squared minus xy. That way if you work that out, it will come back to here, which will come back to your original problem. Those are our steps for doing these types of problems.